Hello, students. Good morning, everyone. I hope you are getting my voice. Okay, guys. Yeah, no one is joined till now. Okay, let me give you. Let us wait for a few more minutes. Let's wait for a few more minutes. If you are getting my voice, just drop me a message. No? If you are getting my voice, drop me a message. Hello, students. Are you getting my voice? Hello students, are you getting my voice? Someone respond, Anna. Someone respond. Are you getting my voice? Good morning, students. Okay, I think two students have joined. Let us continue now. Let us go ahead. Right. So I said the weekend portion part is completed almost, except a small portion, a small part we can say. That is, now we'll see that briefly, and we'll try to work out few numericals, guys. The one which is in need point of view which we have to cover is the relation among elastic constants. Relation among elastic constants. I hope you guys remember what is the weekend portion. For this week we are having bulk modulus, rigidity modulus, and strain energy or elastic potential energy, and yeah, and what do you call it? Of course, in working out this, we may need the concept of Young's modulus also, and Poisson's ratio, and the relation among these elastic constants. So let us see briefly. First, um, the few relations. So write down the subheading, everyone. Relation among elastic constants. Relation among elastic constants. Elastic constants. Elastic constants means like Young's modulus is an elastic constant, bulk modulus is an elastic constant, rigidity modulus, Poisson's ratio, we call them as elastic constants. So let us see the relation among these. The first one let us consider is relation 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 among Young's modulus Y, bulk modulus B, and rigidity modulus is, right. Yeah. So, as what you guys have to remember here is, we are not going to discuss the derivations of these relations, guys. We are not going to discuss the derivations of this, and we'll see briefly only these relations we'll see. Okay, right? Yeah. So exactly what are these relations among Young's modulus, bulk modulus, and rigidity modulus, and also with the Poisson's ratio, how they relate. With Poisson's ratio, how they relate also, we'll try to have a look at. See, first one, the relation among Young's modulus, bulk modulus, and rigidity modulus is given by, I can consider directly as 9 by Young's modulus is equal to 1 by bulk modulus plus 3 by rigidity modulus. This can also be expressed as y is equal to, this implies y is equal to, unsimplifying this by taking the LCM and unsimplifying it. So we will write it as eta plus 3b by b into eta, eta into b. This if you multiply here, you will get 9 eta b, and if you want y, if you take the reciprocal, then we get 9 eta b divided by eta plus 3b is one of the relations. You can take this as equation 1. Equation 1. The next one is, let us try to have the relation between two of these and what you call Poisson's ratio. Two of these and Poisson's ratio. That is Young's modulus, bulk modulus, and Poisson's ratio. So right, let us take next one. Relation among Young's modulus, bulk modulus, and Poisson's ratio sigma. It is given by you can take as y is equal to 3 times bulk modulus into 1 minus 2 sigma. So between yb and sigma, among the yb and sigma. Whereas the third one, instead of yb and sigma, y eta and sigma, if you consider, then relation among y eta and sigma, is y is equal to, it is also given as y in terms of y equal to form only, y is equal to 2 eta into 1 plus sigma, 2 eta into 1 plus sigma. Whereas one more relation we come across except y, so that is the relation between bulk modulus, rigidity modulus, and sigma if what. That is relation among bulk modulus, rigidity modulus, and sigma, that is Poisson's ratio, is, you can take it as a sigma is equal to 3 times bulk modulus minus 2 times rigidity modulus divided by 6b plus 2 eta. Right? This is another relation we have to just remember. These relations, as I told you, the derivations of this we are not dealing with. You guys have to remember these relations while doing the numericals. So then another one important relation is a relation among volume strain, longitudinal strain, and sigma. Volume strain, let us take directly, also can take volume strain, linear strain, and sigma Poisson's ratio. Is, to understand this especially this part, I will give you little briefly. Say for example, if you have a wire, of length L, original length L, and on the ends of this rod, if equal forces F acts on this, so that the length, and if it is initially it is having some radius R. Now on applying this force, if the length of the rod is increased by small amount delta L due to this, so that the final length becomes L plus delta L. Right? Obviously, by looking at this, length is increased here, length increases by small amount delta L as a result of this applied force. As a result of this, the final radius, when length increases, decreases. So the final radius becomes R minus delta R, it becomes. So if it is supposed to have some area and it is in the form of cylindrical shape, area into that length will give you the volume. Volume may remain constant, or I can say that Here, in terms of change in volume, in terms of consider in terms of these parameters, we have to take the expression for volume of cylinder as it is in the form of cylindrical structure. Volume of cylinder is what? Area into length. Area into length, that is equal to area of this is pi r square, pi r square into L. This is the volume. So the change in volume when length and r changes is given by the from the basic chapter called units and dimensions or units and measurements. If you remember, errors change in any parameter can also be called as error in that. So it can be expressed as delta V. Okay, I have to remember that the fractional change in the left hand side part of an equation should be equal to, if you have a product or a division of number of terms, then sum of the fractional changes in the remaining terms. If you are having product of two or more quantities or ratio also, then delta V by V is equal to fractional, pi is a constant, leave it, then the fractional change in r square is 2 times delta r by r plus fractional change in L is delta L by L. So if you want this in terms of sigma, you have to bring the concept of sigma here. Sigma is defined as lateral strain by longitudinal strain. It is minus delta r by delta L by L. From this, if you want this in terms of relation between delta, what is it, volume strain and linear strain, if you want, you have to replace this with sigma. So from this, you can say delta r by r is equal to minus sigma into delta L by L. If you bring it here, this delta r by r, and if you substitute, you will get delta v by v is equal to minus sigma into delta L by L plus delta L by L. You will get, of course, 2 is there, 2 is there, minus 2. So delta v by v can be expressed as 1 minus 2 sigma into delta L by L. This gives the relation among volume strain, linear strain, and Poisson's ratio sigma. You guys have to keep these points in mind. Now, with the help of these and the previous concepts, now let us go ahead with the numericals, especially based on energy, strain energy, and this Poisson ratio based questions. Let us go ahead with some questions. In level 1 exercises, we have already discussed few questions. Now let us do few questions in level 2. Level 2 exercise 1. Level 2 exercise 1. So open page number 85, page number 85, page number 85. Right. Just a second. Yes, now it is reconnected back. Right. Now let us do questions from level 2 exercise 1. So question number. Actually in level 2, based on Poisson's ratio, question number 21, you see, page number 85. Right. It is given that a material has Poisson's ratio of 0.5. If a uniform rod of it suffers the longitudinal strain of 2 to 10 power minus 3, then the percentage increase in its volume is. So what is given here? A material has Poisson's ratio sigma is equal to 0.5. If a uniform rod suffers a longitudinal strain of means delta L by L is equal to 2 into 2 into 10 to the power minus 3. Then percentage increase in its volume is, percentage increase in volume is fractional change in volume into 100 is equal to what? So to understand this, you should recollect back the relation between sigma linear strain and volume strain. That's what just now we have discussed here. So we know that linear volume strain delta V by V is equal to 1 minus 2 sigma into delta V by delta L by L, delta L by L. So you're asked to find percentage change in volume. So into 100 you have to multiply both the what you call LHS and RHS with 100. So we can express this as delta V by V into 100 is equal to 1 minus 2 into sigma is 0.5 into delta L by L is 2 into 10 to the power minus 3. So 2 into 0.5 is 1. So we get 1 minus 1 is what? 0. So we get 0%. So delta V by V into 100 is equal to 0% we will get. So option 1 is the right one. Right, next we'll see few questions based on strain energy. Based on strain energy here in this exercise, already we have discussed a few questions from 22 to 25. We have already discussed. Next, we'll see question number 26. Or let us see in a reverse order from the last question. Let us see from the last question. So what is given in the last question? That is in this exercise, that is question number 32. Let us try to look into question number 32. Question number 32. What is given here is, when a wire subjected to a force along its length increases by 0.4% and its radius decreases by 0.2%. Then the Poisson's ratio of the material of the wire is, Poisson's ratio of the material of the wire is. So what is given here and what you are asked about? This is one of the previous year's question, guys. This is one of the previous year's question. Right. So actually, oh, I have given you this page, but this is not belongs to this AT module, guys. It is from, it belongs to level 2 exercise 1. You just refer level 2 exercise 1, question number 1. Okay, this is also same from same level 2 exercise 1, exercise 1, question number 32. Question number 32. So once again, so what is given, just you guys just you can note down the data part. What is given here is, when a wire is subjected to a force along its length, you can draw pictorial representation. You can draw the pictorial representation of this also. That means, let's say there is a wire uh, and a force is acting along the length, means like this. You can say the length is increased, initial length, so that length is increased by delta L. So the moment length increases, if it is having initial radius, so the radius will decreases by delta R. So you can say that the sigma, by definition, sigma is equal to Uh, that we'll see first. Let us copy the data and what you're asked to find. So that when a wire is subjected to a force along the length, its length increases by delta, increase by 4%. Means length increase by 4% means the percentage increase in length or percentage change in length. Delta L by L gives fractional change in length into 100 gives percentage change in length. That is equal to 0.4. And the radius decreases by 0.2%, means the percentage change in radius delta r by r into 100 is equal to 0.2. Then Poisson's ratio of the material of the wire is, what is Poisson's ratio? Sigma of the material of the rod. What is Poisson's ratio of the material of the rod? We know that we know that sigma is equal to lateral strain by longitudinal strain, that is delta r by r by delta L by L. When one is increasing, another is decreasing, you have to take with a negative sign. You have to take with negative sign. But only the numerical value, if you want, you can take only the numerical value part. Here, into 100, if you multiply both numerator and denominator with 100 by 100 into 100 and 100, you get percentage change. Those values are given here. So then we get delta R by R into 100 is 0.4, delta L by L is 0.2, right? Without a sign we are considering here. Okay. So on simplifying this, what you get is 2 is 4 by 2. So it gives you what? 2. The value of this is 2 or point 0.2. Yes. Delta R by R is 2. Oh, this is 4. Okay, I have taken reverse way, reverse order. So what is given is delta R by R into 100 is 0.2. This is 0.2. Delta L by L into 100 is 0.4. So it is equal to 2 by 4 is equal to 1 by 2 is equal to 0.5. So value of sigma of the given value is obtained to be 0.1 by 2 or 0.5. Okay, you can take it as, of course, the negative sign as well. But here negative sign is not mentioned, so you can take this value. This is how you have to deal with this one. Next, question number 31. Question number 31. Right. Let's see the question. What is given here is a 4-meter long copper wire of cross-sectional area 1.2 centimeter square is stretched by a force of 4.8 to 10 power 3 Newton. If Young's modulus of the copper is 1.2 into 10 power 11 Newton per meter square, the increase in length of the wire and the strain energy per unit volume are. The increase in length and strain energy per unit volume. So what is given and what you are asked to find? Let us see. So what is given here is a 4-meter long copper wire of cross-sectional area 1.2 centimeter square. So length of the wire is 4 meter, and what else is given here? Cross-sectional area delta A is equal to 1.2 centimeter square. You can convert this into units, so it becomes 1.2 into 10 to the power minus centimeters minus 2 meters, so the whole square is 10 power minus 4 meter square. When it is stretched by a force of 4.8 to 10 power 3 Newton, the force applied F is equal to 4.8 into 10 to the power 3 Newton, 4.8 into 10 power 3 Newton. And if Young's modulus of this copper, Young's modulus of the material of the wire is 1.2 into 10 to the power 11 Newton per meter square or Pascal. The increasing length of the wire, what is the increasing length of the wire? Delta L is equal to what? And strain energy per unit volume. Total strain energy per unit volume can also be called as energy density. What is this? What are these things you are asked to find? So, how can you find? First, Young's modulus is given, length and the area of force are given. How to find increase in length? Directly by using what you call the expression of Young's modulus. That's why I said we have to recollect back, then we have to make use of the relations of Young's modulus also while calculating this energy, strain energy. So Young's modulus y is equal to, we know that Young's modulus y is equal to FL by A into delta L. So from this you can say delta L is equal to, by taking this here and bringing y here, we'll get delta L is equal to FL by A into y. A into y. Hmm. Right. So what will happen now? Right. So what is given here? F is what is here? F, L, A, Y all are given. So directly can substituting this, you get the value. So it is what is F? 4.8 into 10 to the power 3. L is what? 4 meter. All are in SI units only. Divided by what is area? 1.2 into 10 power minus 2, or 12 into 10 to the power minus 5 we can write, into Y is 1.2 10 power 11, or 12 into 10 to the power 10 also you can write. So on simplifying this, you can say the change in length or increase in length is observed to be we can say in SI units. In SI units it is 13.2 into 10 power minus 4. 13.2 into 10 to the power minus 4 meters. We get delta L is equal to 13.2 into 10 to the power minus 4 meters we get. That is the increasing length. Whereas the next quantity which you are asked to find is energy per unit volume, called as energy density. We can also call it as energy density. So that is the first thing. Second parameter is, what is that? Small u is equal to energy by per unit volume is equal to half into stress into strain. Half into stress into strain. So as delta L and the original length are given, you can write it as directly half into stress is force by area. Strain is delta L by L. Original length is given, delta L just now we have calculated, F is given, A is also given already. So by substituting them, we will get directly it is equal to half into here, and substituting these values, half into force is what is the value of force given here is 4.8 into 10 to the power 3 Newton, and area is how much? 1.2 into 10 power minus 2 centimeters square. After converting, what you have got? 1.2 10 to the power minus 4, or 12 into 10 to the power minus 5 into delta L is how much? This one, 13.2. 13.2 into 10 to the power minus 4 by L. What is the original length? 4 meters. So if you simplify all these parameters, you will get 6.6 into 10 power 3 joule. What is energy density, right? Energy per unit volume, energy per unit volume. So uh, it will be around, what is this, 6.6 into 10 to the power 3 joule. Small u will be energy density actually, joule per meter cube. I can say it as the total energy part of this per meter cube is 6.6 into 10 power minus 10 per 10 power 3 joule will get. So this is how you have to just work it out. Is it a direct simple numericals? Okay, but the conversion relations you have to take carefully. You have to take them carefully. Next, we'll see next question. That is question number 30. Question number 30. Same level 2 exercise 1. Right. The question given is, this is also one of the previous year's question. The question is, two wires of same material and length but diameters are in the ratio 1:2 are stretched by the same force. The elastic potential energy per unit volume for the two wires when stretched by the same force will be in the ratio. will be in the ratio of what? So what is given and what you are asked to find? So note down two wires of same material. Same material means both are having same Young's modulus. That's what you have to understand. The two wires having same both are made of same material means y1 should be equal to y2. It should be equal to y. Both should have same Young's modulus. Both are made of same material. But just a second. Two wires of same material and length. Its length of two wires also same. And L1 is equal to L2 is equal to L. But diameters of these two are in the ratio of 1 is to 2. So diameter of the 1 by 2 is equal to 1 is to 2 or 1 by 2 are stretched by the same force. So same force applied to stretch them, then same force. The elastic potential energy per unit volume for the two wires when stretched by the same force will be in the ratio of elastic energy per unit volume. We call it as energy density. U1 by U2 ratio of energy density of the two wires will be what is the question. So here you have to just recollect back the what is that expression for energy density. U1 is equal to energy per unit volume is equal to in terms of what you call stress strain and Young's modulus also mentioned. So we can write it as elongation part is not mentioned here. So let us try to ignore the elongation part or strain part. Only in stress part we let us consider because they have mentioned about the force and diameters are given. It's the area part also mentioned. So you can take this as U is equal to U is equal to in general U is equal to in terms of stress and Young's modulus it is a half into stress square by Young's modulus. But stress is force by area, so you can write half into force square by area square into y. Force is constant, same force is applied, so it is also constant. Is number is constant. Young's modulus is also constant. Only the variable parameter is again the diameter is changing, area will change. So area can also be expressed as pi r square, but from this you can also write it as u proportional to 1 by a square are proportional to area is pi r square, so pi r square whole power 4 or power 4 you can take, but diameters are given. I mean r radius can be expressed as diameter by 2, so you can also say this is inversely proportional to diameter power 4. So the ratio of what do you call energy densities are given by u1 by u2 is equal to as inversely proportional to diameter square, so we can write it as d2 by d1 power 4. So it is equal to d1 by d2 is 1 by 2, reciprocal of this is 2. So 2 power 4 is equal to 16 or 16 by 1. Therefore, u1 by u2 is equal to 16 is to 1 you can take. Right? This is briefly about what you call the ratio of energy densities or energy per unit volume of the wires. Okay guys, so these are briefly few numericals based on this. Already the other numericals, similar kind of numericals are given. So practice. I think now everyone has dropped. So if anyone having any doubt, if you drop it, then just I will answer those questions. As no one is there, just I'm dropping it.